Okay, so in your grid paper, okay, we will start off by looking at vectors in 2 dimensions. So I know that you don't have your textbook. So for tomorrow onwards, please bring your volume B textbook instead of volume A. Okay, so vectors generally can be represented in 2 manners, okay, or rather several manners. Some of you, since you do physics, okay, you might already be familiar with vectors itself. Vectors are things that have magnitude and also with direction. Okay, very often in our physics, okay, for those who are taking physics, okay, the vectors that we see will usually be a line segment, okay, that has an arrow within. Okay, we don't usually attach much values. Okay, we don't put it on a Cartesian plane. We don't put it on a grid. Okay, unlike in maths itself, we sometimes put it on a grid so that we can give certain values to it. Okay, it has been a while since I have taught physics, so I don't remember everything. Okay, but I mean this is the best I remember lah. Okay, but definitely there's more relation to physics itself. Okay, so. Okay, in our notes, I want us to at least know that, okay, a vector, or rather a non-zero vector, so I'm just going to adjust this up. Okay, so a non-zero vector, okay, can be represented by a directed line segment. Okay, so this directed line segment, okay, directed would mean that there is certain direction to it. So in vectors, directions matter. Okay, and the line segment, okay, in terms of its length, the length itself informs us about the magnitude. Okay, so you cannot anyhow draw a certain line, okay, and say that that is a vector. Okay, it must be representative of a certain thing. Okay, so it must have a certain value or meaning to it. Okay, which explains why in a vector, okay, usually we have a straight line and then we have an arrow that points in the direction. So, in our notation, you will generally see 2 types of notation. Okay, if I label the endpoints and the start point and end point, so in this case, start point is P, Q is the end point, so start point, end point. Okay, so for this particular vector that I have drawn, I can use the notation PQ with an arrow at the top. Okay, PQ, P must represent the start and Q must represent the end. Therefore, PQ is not the same as QP. Right? QP will in fact be of a different direction. So, they have the same line. Okay, this would be QP, different direction. Okay. Right, so this is one notation that you will commonly see, whereby there is a start point and an end point. Another notation that you will commonly see is this, whereby sometimes instead of having P and Q being labeled, maybe they use a small letter. Okay, in this case I use A, and then there is a tilde sign at the bottom. Okay, it is a curly sign. Right? when in printing, okay, they usually don't print it in this manner. They will print it in bold. Okay, but we do not write things in bold, right? So please don't use your pen and then go around it so many times. Okay, you are expected to do it in writing, and you have to write the tilde sign at the bottom. Okay, very often students tend to forget that, and then they don't lose marks when it comes to presentation. Okay, so just to show you what it looks like in printing. Okay, usually they print it in bold like that. Okay. So PQ, QP, A, all these are representations of a vector. Okay, so it tells us the direction. Okay, so in this case it tells us P to Q. Writing it in this manner doesn't quite tell us much information actually. Okay, it needs to be supported with a diagram in order to show us what is the magnitude as well as the direction itself. Okay. Then, when it comes to magnitude, okay, magnitude is a length. Okay, it is a number, a value. So what we will usually write when it comes to writing magnitude, okay, will be that we put these two lines, okay, outside the vector that we have. So this is regarding magnitude. Okay, we use notations like this, okay, or notations like this if that is how we represent the vector. Okay, so depending on the question, what it uses, okay, adapt accordingly. But we will definitely use that two strokes to represent magnitude. Okay. Right, so these are one way of doing our vector, or rather not doing, but to represent our vectors. Okay, another way is that we will place our vectors, okay, into a grid itself, okay, or what we call is Cartesian plane. Okay, why is it that I use such a grid? Okay, because usually we don't use graph paper lah. Okay, in fact, they will usually not give you the graph paper, they will give you boxes. Okay, very simple grids, okay, for you to draw. Right, I find that this is much more useful rather than our graph paper, because graph paper is finer. Okay, so what I want us to draw now is to draw a grid. Okay, so I want us to take within one box is 1 unit. Okay, so 6, 5, 4, 3. I want us to have up to 6 units. Okay, one box 1 unit. Up to 6, so 0 to 6 for your vertical axis, and then for your horizontal axis, let me adjust this one here. Okay, horizontal axis, I want it to be from 0 to 10. Numbers around the corner. In fact, such paper actually is used for D&T one. I don't think your D&T use this paper anymore, right? You still use such paper when you're in D&T. Clearly, we have age gap. Okay. Now, so in this plane, okay, in this set of axes, okay, it really doesn't matter, okay, whether your axes have negative numbers, positive or not. Okay, having your axis over here is really to inform the reader the scale that you're taking, which is 1 box 1 unit. Okay, because if I were to draw a vector, let's say I call this PQ. Okay. I can represent this PQ with certain numbers. And in this case, PQ, okay, is equals to, we have 3 and then 5. Right? So we represent it like a column matrix, but for vector, okay, because you're doing it in 2-dimensional, there is only 2 values. Okay. And this is the x component, and this is the y component. So the numbers found inside a vector, we call them components, we don't call them elements. Okay? For matrices, we call them elements. Now how do I get the value 3 and 5? Okay? Dimension P is the start point in this particular vector. So the x component is achieved by going in the x direction, the positive x direction. So from the start point, okay, I'm going towards the right, and I see that there are 3 units over here. And then after that I need to move outwards to arrive at Q, and I see that I'm moving upwards in 5 units. Okay? So your components are being calculated by determining how many units it has moved from the start point to the end point in either a horizontal manner or a vertical manner. Okay? So the x component is the number of units in the positive x direction. And 5 is the number of units in positive y direction. Y direction, and therefore in this case it is a -2. So to represent our RS in a column vector, we will have it as 3, -2 in this case. Okay. And all these things are what we call column vectors. Maybe let me squeeze in here. This is what I call column vectors. Okay. Right. So now that we have numbers to represent the vectors, okay, I can find out the magnitude itself already. Right? So to find out the magnitude, okay, the general formula is that if given A equals to xy, for example, okay, the magnitude of A will be square root of the x component square plus the y component square. Okay, so this is to help us to find the magnitude. of PQ will then be square root of 3 squared plus 5 squared. Okay, and that will give us 25 plus 9, so 34. And 34 units. And then when it comes to finding the magnitude of RS, okay, we will have 3 squared plus bracket negative 2 squared. And that's 9 plus 4, so square root 13. Okay. You can leave your answer in exact cert form, or you can leave it in your 3SF, that's also fine. But usually we write it in cert, in exact number. So we have seen our diagonal vectors over here already. What if we have horizontal vectors and vertical vectors? Okay, how would that actually look like in a column vector form? Okay, so a horizontal vector, for example, okay, just squeezing it into this grid here. Okay, maybe let's have this horizontal vector. So this horizontal vector, maybe I'll just call it Mn. Okay. So horizontal vector, we have it called Mn in this case. Okay. You see that starting from M going to N, it is just 2 units to the right. Okay, there's nothing upwards or downwards. So that means that 2 units to the right, the x component is 2, y component is 0. Okay, so that is the column, that is the horizontal vector. So for horizontal vectors, y components are always 0. In contrast, your vertical vector, okay, maybe I will choose to squeeze it here. Okay, so what letters have I not used? RS. Let's call it AB then. Okay, so vertical vector AB, starting at A, okay, there is no left or right direction. It is only going downwards, which is a negative y direction. Okay, so the x component is 0, and the y component will be, in this case, negative 3. So for vertical vectors, your x components are always 0. Your vectors, how is it being represented? Okay, the line itself or your column vector, how to find magnitude itself. Okay, go back, practice your practice now 1A. You may either write it in your textbook, okay, or in your notebook, up to you. Okay, go and figure out what are the column vectors for all these vectors over here. Okay, and then also go and find out what is this magnitude. Okay, practice with this question. Tomorrow we'll come back and check our answers for this. Okay, and then tomorrow we also look into our equal vectors and all that. Okay, please bring this piece of paper tomorrow and your volume E